Hello again. What we have here today is my power supply from an Amiga 2000. I got this I got my 2000 a gazillion years ago on the trade-in year 1000, Amiga 1000, and $1,000, and you get a 2000, which was basically the same thing with slots. So that wasn't really exciting, but I wanted to get this computer going again. I fired it all up, and it was kind of crashy. You know, power supply is probably the first place to look. This thing was super dusty, so I actually washed it off with distilled or deionized water, dried it off really well, and now I'm going to go through and recap any of the capacitors that have to do with filtering to just try to get a little bit cleaner power out of it. This did have a tough life. I noticed, never noticed this before, but a couple of the pins, what I think are grounds, actually have skid marks on them, so not good. So we've got our big box of every single capacitor known to mankind, and we're going to go through and recap this guy. Alright, so let's start out with these two big caps. These are filtering, you can tell, the input, because they're rated for 200 volts, so they're actually filtering the rectified DC. So let's start with that. I like to mark plus and minus just in case I get the capacitor out and it isn't obvious, since these are all polarized. Minus, plus, and this has been sitting around a long time. Otherwise you'd want to short it out, so it wouldn't get zapped. This could certainly zap you long after it's unplugged. So this is plus, and that's minus. So this guy, just put a little pressure on it, and we can probably just walk it right out. And there we go. First cap is out, and I'm going to get the other one out of this, and then we'll test for equivalent series resistance and see how these guys are shaping up and compare them against a brand new one. So it was a 200 volt 60 microfarad. So again, not universal power supply, only runs on 120 volts, so it's a US domestic market power supply. You'd have a different one for Europe, and I don't know if they had a different one for Japan or not. So get this guy heated up. So I'm just putting pressure on the capacitor from the other side. I'll come back later and get the extra soldering. And there we go. So, ooh, yeah, I think that's just glue. So again, same thing. And let's test these guys. Alright, so let's test these capacitors. They should be 680 microfarads. These are rated for 85C. You know, anytime you replace a capacitor, I'd say replace it with a 105C, because there's a chance that it died just from, you know, being dried out in a hot condition. So might as well go up in the temperature rating, otherwise you wouldn't be replacing it. So this is a cool little component tester. Get them on eBay for nothing. I just have some wires come out of the ZIF socket there, and it takes any 3-pin component and tells you what it is: resistor, capacitor, inductor, various types of transistors and MOSFETs. So really cool, and it tells you, like in this case, it's going to tell us the capacitance that it computes and the equivalent series resistance. We have to test these out of circuit. Unfortunately, there's no way to test a capacitor in most circuits. Some exceptions if the circuit's very simple, but most of the time you're going to take it out. So we hook this guy up to 9 volts, and then we hook up the test leads, and I have the colors right, so minus and plus, and you press the test button. Yeah, it's called the GM328 tester. It always says the battery's weak. So 664 microfarads, A little less than 680, but well, actually that probably is out of spec, but not much. I could blame it just as much on this thing since it's just a cheap eBay China thing. Equivalent series resistance 1 ohm. What that means is if you were modeling this, it would be a capacitor in series with a 1.6 ohm resistor. So you can imagine that it's not, no capacitor is obviously just a pure capacitor. There's always going to be some resistance, but that does not look like a old capacitor to me. So let's check out the other one. And also no leaking or anything like that. This one looks a little rough, but I think that's just the glue that was holding them together. And put the little clips up and test. So this one's even better. 662 microfarads and 0.8 ohm series resistance. The series resistance also tells you how fast, well, the RC constant, basically how fast it's going to be able to drive current. So I know I have some new ones I picked up for this. It's a bit unusual size since they are rectifying line current. 200 volt capacitors aren't something that I have laying around, so I did have to go off to DigiKey. So let's measure a brand new one, see what it says. I have a feeling it's going to be just about the same. Notice it's a cap. Look at that. Now, I don't know how these things behave at 200 volts. You can't really non-destructively measure the breakdown voltage of a capacitor, at least not one. Well, yeah, you're not going to be able to do that. So we'll replace it, but it's probably this, whatever this problem is I'm having with crashing, is probably unrelated to these caps. Alright, we're just going to make some notes so I don't forget what value goes where. I want to do these three big ones for sure, especially this one because it's right near where the lead goes off to the motherboard, and so chances are that's a pretty important capacitor. Now I notice these are, that one's 105 rated, 105, and that one's 105 rated. This little guy here, so if I draw this out, the heatsink, yeah, and the inductor. Again, just so I remember where these go. I have a picture, but the picture doesn't have the values. That guy is 300, 10 volt, 330 microfarads. The tall one is hard to read. 16 volt, 330. And the last one is 10 volts, 3300. Now that looks the same as this one, so let me just double check. That's not 3300. It is also 3300. You can also replace a capacitor with a capacitor of greater voltage. You know, obviously you want to stay within the footprint, but the higher voltages is the breakdown voltage. So if you go higher, that's only good. And these are all 105 already, so we definitely want to replace these with ones rated for 105C. Alright. Heat it up and kind of yank it out here. Just put some pressure on there. Yep. Okay, there's that guy. And this one. For stuff like this, I like a pretty high wattage. This is a 25 watt soldering iron. Something much more than you'd, and it's just warming up. You would never use something like this to drag solder or to work on surface mount. But desoldering, we don't want to waste your time. More watts is better. Just don't lift traces. Alright, let's take a look at these capacitors. The first one is one of the short ones, 10 volts, 330 microfarads. Hook this up. Well, great shape, 3400 microfarads. And there's the tall one, or no, yeah, the tall one, which is a 16 volts at 330 or 3300. Test. Ooh, that one's really good. So maybe this that last one wasn't that great. It was actually overvalue. But that should not hurt a filter capacitor. The more capacitance, the better. The less series resistance, the better. And the last one, this is a 10 volt, 3300. Ooh, very nice. So maybe that 16 volt did have a tough life. You'll notice that the, let me unplug this. I actually did not need to mark the polarity on these guys because if you look here, for instance, you can see that block that indicates negative, or the white stripe, and that matches. So I can just mark it up there to make it more visible. This one here is going to be on top, yeah, and that is also negative. So on these, there's a square indicating the white bar for negative, negative, negative. So I think since those are all the big ones, I'm going to go ahead and repopulate these. Alright, pardon the background noise, we got the fan going, and we're going to use this. This is a heated solder sucker. You may have seen just the regular solder suckers where you solder and then quick swap in the solder sucker. They work, but this works really well. It's 40 watts, so let's make sure these pads are clear. Just gonna wait till it's shiny, and then hit the button. And boom, empty hole, just like that. Reset. That looks pretty good already. Empty hole. Okay, let's get these over here. Okay, let's put in the big guys first. Make sure they're flat. Okay, nice warm joint. Let that cool. Double check the polarity. Yep. And put in this one.